The Thermite reaction, one of the most dangerous and famous chemical demonstrations to ever grace a classroom, which is surprising given the availability of the ingredients. The popularity of this reaction has only increased due to its cameos in movies such as Black Hawk Down and TV shows such as Breaking Bad. I'm going to add my own contribution to that media by destroying some gingerbread houses at the end of this video. Don't tell my kids. Now listen, it goes without saying that this is a very dangerous reaction. Enjoy this vicariously through videos such as this and other videos that grace YouTube. Now, even though I've been doing this reaction for 20 years, this reaction has been around for quite a while. It was discovered 120 years ago by a German chemist named Hans Goldschmidt. Known eponymously as Goldschmidt's reaction, it was originally intended to purify ores, but the industrial applications soon became readily apparent. Once this reaction starts, this self-sustaining inferno is capable of welding or even cutting through metal. Given the fact that water is rarely enough to stop this reaction, it even has applications for underwater welding. Now, despite the fact there are dozens of combinations that could get you a thermite reaction, there is one common mixture of ingredients that is by far the most popular, and that is a powdered mix of an iron oxide and aluminum. The iron oxide can be a mix of different types of iron oxide, iron 2 oxide, iron 3 oxide. The reason these iron oxide compounds are used are because A, it's relatively inexpensive, it's essentially rust, therefore it's pretty safe to use, and it's a good source of a metal that can be bullied into taking back the electrons it lost to make the bond. You can even manipulate the ratios of these different types of iron oxides to get a mixture that ignites at a lower temperature or even burns at a higher temperature. Now, the real star of this reaction is aluminum metal. Now, why is that? Aluminum is essentially the Goldilocks of reactive metals. Now, it might surprise you to think of aluminum as a reactive metal, but it is. Most of the aluminum you run into has already oxidized and created a protective coating, so you don't see it as a reactive metal. Aluminum has a low melting point and a relatively high boiling point. This allows the reaction to start at a pretty low temperature and then reach pretty extreme temperatures. This can be a tough reaction to start. It's got a pretty high activation energy. Now, there are many techniques to get this started. I've used potassium permanganate and a glycerol mix. I've used secondary thermite reactions on sparklers to start the main reaction, and that's how I injured myself. That is a story for another day. Lately, I've settled on magnesium as a starting fuse. The magnesium itself requires a pretty high temperature to get started, but if that magnesium fuse burns down into the thermite pile, you're pretty much guaranteed for the reaction to start. I will admit this is a relatively temperamental way to start the reaction. I would say magnesium ribbon, you can usually get started 2 out of 3 times. So once this reaction gets started, you essentially have what's called a single replacement reaction. The aluminum, being a more active metal, can make a stronger bond with the oxygen atoms. And so once that temperature gets high enough, the aluminum will actually kick the less active iron out of those bonds and create the much stronger aluminum oxide bond. Now, this releases an extreme amount of energy. This exothermic process releases enough heat to melt both products, both the iron and the aluminum oxide. And that's important because that allows the molten aluminum oxide slag to separate from that iron that can be used for the industrial applications, such as welding railroad tracks. Now, just because it's hard to light doesn't mean it's impossible to light. I would always recommend an extreme amount of caution around thermite mix. Some sparks are hot enough to get this started, and people that used metal grinding equipment around aluminum have to be especially cautious to make sure they don't accidentally start a thermite reaction. So on to the gingerbread houses. Now, I thought the slanted roofs of the gingerbread houses would help a little bit, but I was surprised in this first reaction how much they actually withstand damage. The molten metal does not get to spend very long on the gingerbread house, and so it bounces off the sides, leaving the gingerbread houses relatively unscathed. So I learned from my lesson, and so in the second attempt, I put 2 gingerbread houses next to each other so that the molten iron would be forced to stream down the middle. Success. Yeah, I burned those things pretty well. Then what I did is I decided to crack the gingerbread house open to make sure that the molten iron got down to the inside of the gingerbread houses. And again, a lot of success there. If you found anything about this video helpful, please consider liking and subscribing to the channel. If you ring the bell for notifications, you'll know when I upload new videos, like the upcoming story about when I burned myself with the thermite reaction. Emotionally and physically scarring to me, but perhaps I can best serve as a cautionary tale to you. Thanks for watching, and have a great day. It was discovered 120 years ago.